In this lesson, we're going to continue with the study of factoring polynomials. This is IA9. Last lesson, we factored polynomials by factoring out the greatest common factor, and we did some grouping. So if we take a look at our factoring flowchart, we have done this, greatest common factor, and then we had some polynomials that had 4 terms, and we did some grouping. Today's lesson, we're going to take a look at polynomials that have 3 terms. Take a look at trial and error and perhaps perfect square trinomials. All right, before we're going to actually factor, let's do a little bit of review of FOIL. Suppose we had, I'm going to do 4 examples. Suppose we have x plus 2 times x plus 5. When I multiply these, I do the product of the first. X times x gives me x squared. The outer product is 5x. The inner product is 2x. The sum of those is 7x. The product of the last is 10. When I multiply a binomial times a binomial, and there are pluses in both factors, I get pluses in the product. Let's look at our second example. Suppose I have x minus 2 times x minus 5. I will get product of the first, x times x is x squared. The outer product is negative 5x. The inner product is negative 2x, which gives me negative 7x. The product of the last, negative 2 times negative 5, is positive 10. The sign pattern's changed. Anytime you multiply a sign times itself, whether it's positive times positive or negative times negative, you get a positive product, and in this case a positive 10. But if the signs here are both positive, your inners and outers are positive, the sum of them is positive. If both signs here are negative, then the outers and inners are negative, their sum is negative. So please notice that so far. Let me get a little bit more space. All right, for my third example, suppose I have x plus 2 times x minus 5. The product of the first is still x squared. The outer product is minus 5x. The inner product is positive 2x. So instead of adding those, I'm going to subtract and keep the sign of the larger one for minus 3x. The product of the last, it's a positive times a negative, I get negative 10. If I change up the signs so that I have x minus 2 times x plus 5, x times x is x squared. The outer product is 5x. The inner product is negative 2x. The signs are different on those, so I subtract and keep the sign of the larger, so I get plus 3x. The product of the last is still minus 10. So now let's take a minute to compare the third and fourth examples. In each of these, I have one plus factor and one minus factor, but they are associated with different numbers. No matter what, when I multiply a positive times a negative or a negative times a positive, I get this negative 10. If the larger number, 5, instead of 2 is the negative, then that difference is negative for the middle term. If the larger number, 5, is positive, then the middle term is positive. We're going to try to remember some of those characteristics. Here is a pattern chart It says if all of your signs are, let me back up. If the last sign is positive, then both factors have to either be plus plus or minus minus in order to get that positive last term, and the middle term tells you which case it is. So if the last sign is positive, you either get plus plus for the factors or minus minus for the factors. The sign of the middle term tells you which one it is. If instead the last sign is negative, you always get 1 plus and 1 minus in the factors. 1 plus and 1 minus. Now, how they line up with the numbers depends on the middle term. And we'll talk more about that as we look at some examples. So let's take a look at problem number 1 in the notes that will be associated with your homework. The first thing I do, the instructions say factor the trinomials completely. This trinomial, even though I'm not on a lesson about greatest common factor, I always look for a common factor, but I don't see one. Because it is a trinomial, I think that it is the result of having multiplied two binomials with FOIL. So to factor it, I'm going to undo the FOIL. So maybe I haven't made a big enough comment about this, but when you factor, you are finding what multiplied, and I'm going to abbreviate that, together to get this polynomial. You're finding what was multiplied together. So in this one, I'm going to talk about the signs. The last sign of the trinomial is positive. That means that the signs inside the factors are either plus plus or minus minus. The middle term sign tells me that they are plus plus. I'm going to think about FOIL. The product of the first has to give me x squared, so it has to be x times x. Now, the outer product plus the inner product, that's a little messy, have to add up to be 12x. The last times the last has to give me 32. So I'm looking for two numbers, and they must satisfy two conditions. First of all, they have to multiply together to give me 32. That means that it could be 1 times 32 it could be 2 goes in there 16 times, 3 does not go into 32, 4 goes in there 8 times, and I think those are all the factors. Any of these pairs would work to multiply this times this to give me 32. But I have to select the pair that also add up, because of outers and inners, to be 12. That means that I'm going to choose 4 and 8. So I'll put in a 4 and I'll put in an 8. It does not matter which order you put them in. Let's check and see if we have the correct factors using FOIL. X times x, that's the first, that gives me x squared. The outer product is 8x. The inner product is 4x. Those add together to be 12x. Product of the last 4 times 8 gives me 32. I have the correct factors. So in my math lab, that is what you would type in. Let's look at the next one. I'm asked to factor. I think about greatest common factor, but I look at all these terms and there is not a common factor. The next thing I do is count 1, 2, 3. Because it is a trinomial, I will do this process, which is formally called trial and error, but I don't think we're going to make any errors today. All right, I like to work on the signs next. The last sign is positive. That means that it is either a plus and a plus or a minus and a minus. Because the middle sign is negative, it is a minus and a minus. Now I know that the first times the first has to give me x squared, so it's x times x. The product of the last have to multiply together to give me 8. So it's either 1 times 8 or 2 times 4. To decide which it is, I must also think about the outer and the inner products. They have to combine to be negative 9. Which of these will add to become negative 9? Well, these will. So I will put in a 1 and an 8. It does not matter about the order because the signs are the same. The product of the first, x times x, is x squared. The outer product is negative 8x. The inner product is negative 1x. Those combine to be negative 9x. Negative 1 times negative 8 is positive 8. I have the correct factors. So when you're answering MyMathLab, this is what you'll type in. You're finding the factors that would multiply together to give you the original trinomial. Let's look at this next one. Factor, that means look for a common factor, but there's not one. Trinomial, so I will put my 2 sets of parentheses. Signs, if the last sign is positive, then it is either plus, plus, or minus, minus. The middle term tells you which it is. It is plus, plus. The product of the first have to give me x squared, so x times x. The product of the last have to give me 16, so that's either 1 times 16, 2 goes in there 8 times, 3 doesn't go into 16, or it could be 4 times 4. You are welcome, especially with bigger numbers, to use calculators to figure out what the list of factors will be. These need to add up because the outers and the inners will add up to be 8x. That means this is my choice. It is 4 and 4. Product of the first is x squared. The outer product is 4x. The inner product is 4x. That means their sum is 8x. Product of the last is 16. Now let me take just a minute and point out to you that this is a perfect square trinomial. Now you can factor it just fine without recognizing that, but in the future it may be helpful to understand what a perfect square trinomial is and what it looks like. A perfect square trinomial can be found by squaring a binomial. Look back over here. It's x plus 4 times x plus 4. That means it could have been written as x plus 4 quantity squared. Because it is the result of squaring something, it is called a perfect square trinomial. What do perfect square trinomials look like? Let me copy that down. The way you identify a perfect square trinomial, the first term must be a perfect square, and it is. The last term must always also be a perfect square, and there has to be a positive sign. Now, with the first term being a perfect square and the last term being a perfect square, this is a strong candidate, but it is not for sure yet. You could say, I believe that I will take the square root of the first one, the square root of the last one, the sign from the middle, and I think that's right, but let me double check it. Do you recall your squaring process from another lesson? If you were squaring this, you would square the first. Yes, there it is. Now, to get the middle, you multiply these and double it. And that's what you use to do the final check. That does check. The product of those is 4x, double it for 8x. The last one, 4 squared is 16. So you might be able to tell that these are your factors without doing trial and error. But you don't have to. All right, let's look at number 4. There is no greatest common factor. It's a trinomial, so I will put my parentheses. Now let's talk about the signs. For the first problem, we have a negative. When we have a negative, it is automatic 1 plus, 1 minus. You will find it is my habit to put the plus first, but that is not a rule. It's just a habit of mine. Now let's take a look. First times first has to give me x squared. So x times x. I'm going to have an outer product which is negative, and I'm going to have an inner product which is positive. That means that when I combine them, I won't add, I will subtract and keep the sign of the larger. So as I write down factors, I'm not looking for two factors that add up to be 2. I'm looking for two factors that subtract to be 2. Now to get a 15, it's either 1 times 15 or 3 times 5. Do any of those give you a difference of 2? These do. Does it matter where I put them? Yes. Because they have different signs, it makes a lot of difference where you put them. The sign of the middle tells you where you will put the larger. So I will put the 5 with the negative and the 3 with the positive. Let's double check it. X times x gives me x squared. The outer product is negative 5x. The inner product is positive 3x. Subtract, keep the sign of the larger. That gives me 2. And the negative being with the 5 gives me negative 2x. Finally, positive 3 times negative 5 gives me negative 15. You have to think a little bit more when you're dealing with a last term that's negative, because you're looking for factors that subtract to give you the middle value, and you have to remember that the larger of the two factors will go with the sign that you see right here. All right, let's look at number 5. Factor, no GCF, so I will go straight to my parentheses. The last sign is negative. That tells me 1 plus and 1 minus. Blank times blank gives me x squared. That's x times x. I will need an outer product that's negative and an inner product that's positive. And these two quantities have to multiply together to give me 3. Well, there's only one way to get 3. 1 times 3. Do those have a difference? Subtract a difference of 2. The answer is yes. The larger of the two numbers will go with the positive sign. So the 3 will go with the plus and the 1 will go with the minus. Let's double check it. X times x is x squared. The outer product is negative 1x. I know you don't usually write the 1. 3 times x gives me 3x. Combining these, I would get subtract and keep the sign of the larger, positive 2x. Let's look at number 6. Factor, so I think GCF. I haven't had one, but it's a possibility. When I don't have a greatest common factor, I go ahead and jump straight to the fact that it's a trinomial. The last sign is positive. That means plus plus or minus minus. The middle sign is plus, so it's plus plus. To get the x squared, I need x times x. I'm going to have a positive outer product and a positive inner product. They'll have to add up to be 11. And these last numbers have to multiply to give me 5. Well, there's only one way to get a 5, and that's 1 times 5. But do 1 and 5 add up to be 11? And the answer is no. You could try them, but there's really no need because the outer product would be 5, the inner product would be 1, or vice versa. All you can possibly get is 6x. What that means is I did not need to do this. This polynomial is prime. There is no way to factor it and get two factors other than this times it, the polynomial times 1, and we don't bother to do that. So you cannot factor this polynomial. It is prime. Let's do some. Factor this. I don't see a GCF, so I'll go straight into trial and error. Last sign is positive. That tells me plus plus or minus minus. In this case, plus plus. So I know that x times x gives me x squared. My outer and my inner will have to add up to be 16, but let's take a look at 55. 1 times 55, that doesn't do it. 5 times 11, 5 times 11 is 55. What's 5 plus 11? It is 16. I have the right numbers. Because these signs are the same, it does not matter how you write them down. That gives you an outer product of 11x, an inner product of 5x. Yes, that gives me 16x. Number 8. I'm so sorry about that popping in there. All right, we're going to actually have quite a few of these to do, so I'm probably not going to do a lot of checking or discussion. We're just going to work through the problems. In factoring the trinomial, the last sign is negative. That always means 1 plus and 1 minus. I need x times x to give me x squared. Now I need this last times last to give me 18. It could be 1 times 18. 2 goes into 18 9 times. 3 goes into 18 6 times. My outers and inners have different signs. That means I'm looking at a difference. Which of these has a difference of 7? It would be right here. Of those two numbers, what goes where? Remember that when they are different, that the larger goes where you see that sign. So the 9 will go here and the 2 will go here. Double check it. X times x is x squared. Outer is negative 9x. Inner is positive 2x. That gives you negative 7x. 9 times 2 times negative 9 is negative 18. Number 9. Factor. Don't see a GCF, so go ahead with your trial and error because it is a 1, 2, 3 termed polynomial. Last sign is positive. That means plus, plus, or minus, minus. So in this case, it's plus, whoops, so sorry. It's minus, minus because that negative sign right there. So I need x times x gives me x squared. Now I'm looking for factors of 14. That's 1 times 14 or 2 times 7. Because the signs are the same, their sum has to be 9. So it's going to be 2 and 7. The signs are the same, so it doesn't matter what goes where. Product of the first, x times x is x squared. Outer product, negative 7x. Inner product, negative 2x. Those add up to be negative 9x. All right, starting with number 3, you're going to see something a little bit different. It's still a trinomial to factor, but do you notice that the leading coefficient is something besides 1? That means that it is significantly more difficult and that you may have to make an error and check it. You won't know, and so we may be doing some erasing. All right, let's start. We do not see a GCF, but I am going to put my two sets of parentheses and put my signs. My last sign is negative. Anytime the last sign is negative, it's always 1 plus and 1 minus. It doesn't matter which one you put first, which one you put second, but you do have to have one of each. Now, I am still going to need an x and an x here, but the difference is their product has to be 3x squared. Well, there's only one way to get a 3, and that's 1 times 3. So I'm going to put the 1 and the 3. All right. Now, to get a 2, there's only one way to get a 2. That's 1 times 2. But there's much to consider. I'm going to put 1 and 2 in there. And if I don't get what I want, then I will move them. Okay, I'm just going to put 1 there and 2 there. It is now that you try and see if you got it right. Here, the outer product is negative 2x. The inner product is positive 3x. If you combine those, you get 1x. That is not right. Since, I will erase that, the only thing that I'm going to change will be the positions of these. I do not change the positions of my first ones. Otherwise you could get way too many things and get confused. So now I'm going to put the 2 first and the 1 second and see if that makes a difference, and if so, is it correct? Now this 1x is lining up with the negative 2. That gives me negative 1x. The 2 is now being multiplied by the 3x. That gives me 6x. 6x minus 1x does indeed give you the 5x that you want from up here, but the sign is incorrect. If you do everything and you get the right quantity, but with the wrong sign, then all you do is change the signs. Now, the outer product is positive 1x, the inner product is negative 6x, I get negative 5x, and that's correct. So there's so much more to consider when the leading term is something besides a 1. If you just have one choice, you put them in there and anchor them. Then you look at your possibilities for the last. You put them in. If they're not right, you switch them. And once you get the right numerical value, if the sign's wrong, you change the signs. All right. It's called trial and error. Don't be afraid to make a mistake because you have an eraser. Number 11. Factor. I don't see a greatest common factor, so I'll put my parentheses. The last sign is negative. That means 1 plus and 1 minus. They may or may not be in the right spots. I know that I will need an A and an A. To get a 5a squared, the only way to get 5 is with a 1 and a 5. I will not move those. To get a 32, I will need 1 times 32, or 2 goes in there 16 times. 3 doesn't go in there, 4 goes in there 8 times. And one of those is right, but I don't know which one. So I try with the possibility of making an error. So let's see. Start anywhere you want. I think I will start with 4 and 8. So I'm just going to put 4 and 8. And it is all about outers and inners. In this case, the outer product is negative 8a. The inner product is 20a. subtract for 12a, and that's wrong. I always say that the next thing you should do is change the place of those. Put the 8 here and the 4 here. So this is the second thing I'm checking. Now the outer product is negative 4a, the inner product is positive 40a, and it got a little bit worse. Now my middle term would be 36a, and it's not. All right, I have checked this both directions. It didn't work. Done. It is not, 4 and 8. So I will erase. The next thing I'll try is 2 and 16. This time the outer product is negative 16a, the inner product is positive 10a, and yay! Positive 10, negative 16 gives me negative 6a, and that's what the middle term is. So I found it right here. There is a possibility on a problem like this that you would take test 4 and 8, 8 and 4, 2 and 16, 16 and 2, 1 and 32, 32 and 1. There are a lot of things you might check before you get the right answer. And what's really sometimes irritating is you check everything and then find out that it is prime. So your factors here, most probably that 1 should not be written. I just did it in our work. Let's look at our next one. Number 12. Factor means look for a greatest common factor, but I don't see one. So because it's a trinomial, I would go with trial and error. The last sign is positive. That means plus, plus, or minus, minus. Well, the middle term tells me it is minus, minus. I know I need an x and an x, but I have even a more complicated situation now. Because to multiply these first and get 6x squared, it could be 1 times 6, or it could be 2 times 3. I don't know which one. To get the last, to get this last times this last to give me 10, it could be 1 times 10, or it could be 2 times 5. I don't know which one it is. Unless this number is, okay, I lost my train of thought for a minute. I was going to say that unless this middle term is extremely large or maybe even extremely small, I tend to stay away from starting with the most spread out factors. Now, that's just, remember, it's trial and error. So I'm going to start with 2x and 3x. And I'm going to start with 2 and 5. Now, these 2 and 3 I'm going to anchor. I will not change their positions. I'm going to try the 2 and 5, and if that doesn't work, I will switch it to 5 and 2. So let's just see what's going on. In this case, the outer product is negative 10x. The inner product is negative 6x, and those add up to be negative 16, and that's incorrect. So I will hold the 2x and 3x where they are and change the 5 and the 2. This outer product is negative 4x. This inner product is negative 15x. And those add up to be negative 19x. So yay, it only took 2 tries and it works out. So when you put this into my math lab, this is exactly what you will put in. So maybe that was just luck that I started with 2 and 3 and started with 2 and 5, and it took me that second try moving the 2 and 5. But that's what I mean by try and error. Sometimes you try, sometimes you get it first time, sometimes it takes 6 times before you get it. Let's move on and see what happens with the next one. No common factor, trial and error because it is a trinomial. Signs. The last sign is positive, and the middle one is positive. That means plus plus. I have y and y. To get a 6, I need 1 times 6 or 2 times 3. To get a 2, all I have is 1 and 2. So, suppose I start with 2 and 3, 1 and 2. The outer product is 4y. The inner product is 3y. That adds up to be 7, and that's not right. So I switch it. I put the 2 here and the 1 here. This gives me an outer of 2y, an inner of 6y. Those do not add up to be 13y. So what I know is I tried 2 and 3, anchoring them and never moving them. I tried them with 1, then 2, and then 2, then 1. That didn't work. So I will switch to 1y and 6y. 1 and 2, 1 and 2. The outer product is 2y. The inner product is 6y. No, that does not add up to be 13. I only have one more thing to try. Lost my y. Try the 2 in here and the 1 out here. Outer product, 1y. Inner product, 12y. Add them together, 13y. So I tried the 2 and 3. I tried it 1 and 2, 2 and 1. Did not work. Then I went to 1 and 6. I did 1 and 2 and then 2 and 1. So I think this took me 4 tries to get it right. But we did. Ooh, this next one looks like it's got big numbers. All right, that may mean that we have more trials, but then maybe not. The last sign is positive. That means plus plus or minus minus. Since the middle term is minus, it means minus. I will sneak in my x. To get first times first gives me 21x. It's either 1 times 21 or 3 times 7. Now to get 80, I actually have quite a few choices. 1 times 80. I'll try 2 goes into 80 40 times. 3 does not go into 80. 4 goes into 80 20 times. 5 goes into 80, you use your calculator if you want to, 16 times. 6 doesn't go in, 7 doesn't go in, 8 goes into 80 10 times. I have a lot of choices. Well, I'm going to start with 3 and 7. I'm not moving those till I've checked everything. And I'm going to start with 8 and 10. 8 and 10. Outer, inner. The outer product is negative 30x. The inner product is positive 56x. And, whoops, I'm sorry, it's negative 56x. Look at that. I'm pretty excited about that because those add up to be 86x. We got the first answer on the first trial. So sometimes that happens and I'm pretty excited. We chose 3 and 7, we chose 8 and 10. First try they lined up correctly. All right, let's keep practicing. All right, number 15. Going to factor it. I think I'll step over here. I don't see a common factor. Last sign is positive. That means plus plus or minus minus. The middle one is plus, so it must be plus and plus. I know I'm going to sneak in the y and the y. Now, in thinking about this, I need to get my outers and inners to add up to be 5. And that seems a little bit small, but let's go further. The 16, for the first terms, it's either 1 times 16, 2 times 8, or 4 times 4. To get a 10, it's either 1 times 10 or 2 times 5. I do not think right now that there's much of a chance that I'm going to get my outers and my inners to add up to be only 5y. But let's try. Let's try the small ones. If I try 4 and 4, and I try for the last 2 and 5, you can see immediately the outer product is 20y. That's already too big because these are plus. No matter, and that was the smallest thing I could check. That's the very smallest. What that means is that middle term is so tiny, there's no way that I can work with these to get the outers and inners to be only 5y. This polynomial is prime. You could try, you've got your 4 and 4, you can try 2 and 5, 5 and 2, you can try 1 and 10, 10 and 1, go up and then start over with 2 and 8. But when the smallest combinations are too big, then everything is going to be too big. That one didn't work out. Number 16. No common factor. The difference here is I have an a squared and a middle term that has an a, but I also have a b squared and a middle term that has an ab. So what that's going to mean is some extra letters. The last sign is positive, so it's plus plus or minus minus, and the middle term is plus, so it is plus plus. Not only am I going to have A's on the first, but I'm going to have B's on the last. And now I do it the way I've always done the problem. To get a 7, well, that's nice. There's only one choice, 1 times 7. To get a 3, there's only one choice, 1 times 3. So if I put in 1a and 7a and 1b and 3b, let's look. The outer product, 1 times 3 is 3, and then a times b, 3ab. The inner product is 7ab. Those add up to be 10ab. When you type it in MyMathLab, you would of course not write the ones, so it will look like a plus b parentheses 7a plus 3b. I always write the ones to make it exceptionally clear about what I'm using, but don't type them in to MyMathLab. Let's look at 17. Look at all the terms, no common factor. The last sign is negative. That means 1 plus and 1 minus. I may or may not have them in the right spot. I need A's with the first, but because of this, I need B's with the second. 3, well, there's only one way to get 3, 1 times 3. But to get 32, it could be 1 times 32. 2 goes in there 16 times. 3 doesn't go into 32. 4 goes in there 8 times. So those are my choices. I have to start with 1 and 3, and I'm going to go ahead and start with 4 and 8. It may or may not be right. Outer, inner. Outer product is minus 8ab. The inner is positive 12ab. Remember, the signs are different, so I'm subtracting. That gives me 4ab, and that's not correct. So I will swap them. Remember, the first thing I do, I tried 4 and 8, so now I change it to 8 and 4. The outer product is minus 4ab. The inner product is positive 24ab. That gives me 20, and that doesn't work. So what I know is 4 and 8 doesn't work. Let's try in 2 and 16. The outer product is negative 16AB. The inner product is positive 6AB. When I subtract, there it is. Sometimes I want to celebrate. I get so excited when I get the answer. So your answer as you type it into MyMathLab will be A plus 2B times 3A minus 16B. The secret is always to check over and over your middle term, your outers and inners, to see if you're getting the middle term. Number 18. All right, it says factor the trinomial, and I look, and hopefully you notice we've gotten through 17 problems and we haven't seen it, but all of a sudden there is a common factor. 5 is a common factor for each of those, and that's a good thing, because when you factor out a greatest common factor, the new trinomial you get will have smaller numbers. So I'm going to divide each of these by 5. That gives me x squared minus 11x plus, and 5 goes in there 24 times. From now on, this 5 is a tag-along, and I will no longer worry about the original problem at all. It doesn't even exist. All I worry about is this trinomial. The last sign is positive. That means plus, plus, or minus, minus. Because that's minus, it will be minus, minus. There's an x, there's an x. I need factors of 24. Remember, you're ignoring this 5. He's on the outside. So it's either 1 times 24, 2 goes in there 12 times, 3 goes in there 8 times, 4 goes in there 6 times. There's a lot of ways to get 24. The outer and the inner will both be negative. Because there's no coefficient here, I can just look at these numbers, and 3 and 8 will add up to give me the 11. So I go straight to 3 and 8. The outer product is negative 8x. The inner is negative 3x. That's negative 11x. If you want to check all the way back up to here, then you would do the distributive property. In MyMathLab, for a final answer, you will say it is 5 times x minus 3 times x minus 8. And of course it would be fine if you had 5 times x minus 8 times x minus 3. So this is the first problem we've had of factoring where it took 2 steps of factoring. There was a greatest common factor, then trial and error. Number 19. To factor this, and I'm thinking about greatest common factor, but I'm also noticing, and I don't know if we made much of a deal of it, but when the leading term of any polynomial to factor is negative, you must factor out a negative common factor. And since the only thing I can factor out is a 1, I will factor out negative 1, which means I divide all those by negative 1, and that's going to cause their signs to change. That gives me positive x squared minus 13x minus 30. Keep either a negative 1 or just the negative sign. The last sign is negative. That means 1 plus and 1 minus. This is a single x squared, so x and x. I need factors of 30. Because it's 1 plus and 1 minus, they're going to have a difference of 13. So it could be 1 times 30. It could be 2 times 15. It could be 3 times 10. They need to have a difference of 13. It's going to be these. The signs are different. Remember, this is the sign of the larger when they're different. At least you can say that when that leading coefficient is a 1. When that leading coefficient is something different and you have factor choices over here, then you just have to test everything. So in this one, I will put the 15 here and the 2 here. I still check it. That's negative 15x. That's positive 2x, which gives me negative 13x. Then if you distribute the negative 1, you'll get all the way back up to here. So in MyMathLab, you could just put a negative sign in front of x plus 2 times x minus 15. The 1 would be implied. Number 20. Let me get a little more room. All right. Once again, I have a trinomial to factor looking, and I see a GCF. I see an x cubed, an x squared, and an x. All right, so x is a common factor. 11 does not go into those, so there's no numerical common factor, just the x. That means that you divide x into each of those. That gives me x squared minus 100x minus 100. All right, now I'm going to keep my x and see about trial and error. Okay, I lost my 11. It's back. That certainly makes a difference. The last sign is negative, which means I need 1 plus and 1 minus. I have an x and an x. All right, 11. There's only one way to get 11, 1 times 11. The 100 down here, it's either 1 times 100, 2 times 50, 4 times 25, or 10 times 10. So I have to start with 1 and 11. I got a little spoiled in the last two problems because the leading term here, once I took out the GCF, was a 1. Well, this is not a 1. I have a 1 and an 11. I'd like to start with the factors closest in, so I'm going to go ahead and start with 10 and 10. This gives me an outer product of negative 10x and an inner product of 110x. Well, that's pretty good. I take that difference and I get 100x. I do need negative 100x. So since it's the right value but the wrong sign, I change that to minus and that to plus and double check it again. Now the outer product is plus 10x. The inner product is minus 110x. That gives me minus 100. When you type this in, keep the outer x that was a GCF, open parentheses, x minus 10 rather than 1x times 11x plus 10. Never forget your GCF. All right, I have already talked about about perfect square trinomials, but we're going to go over it a little bit. They are really telling you, it says factor the perfect square trinomial. Now, if this is a perfect square trinomial, which it is, and they're telling you so, then your answer is going to have a square, and it will be the square root of the first term, so that's x. It will be the sign from the middle, that's plus, and the square root from the last, which is a 4. I recommend that you test it by the squaring process. You square the first, multiply for 4x, double for 8x, square the last for 16. It checks. Let's look at the next one. Factor the perfect square trinomial. Well, they're telling you it is, open parentheses, it's squared. Square root of the first is x. Sign from the middle is minus. Square root of the last is 9. Check it. X plus 9, quantity squared. Square for x squared. Multiply for minus 9x. Double it for negative 18x. Square the last for plus 81. It checks. I'm sorry about my sniffles. Well, I hope this is a perfect square trinomial. That will make it easy. The fact that this is a perfect square and this is a perfect square makes it a strong candidate. We will check it. The square root of 64x squared is 8x. Sign from the middle, minus. The square root of 49 is 7. Let's check it. 8x minus 7 quantity squared. Square that for 64x squared. Multiply for negative 56x. Negative 56 times 2 is negative 112x. Square the last for plus 49. Yay, that worked. And I think we have one more. Yes. It says factor the trinomial completely. 3, I believe it goes into 42, and check it with the calculator. 147 divided by 3, 49 times. Okay. So common factor, GCF. You never know when the GCF will pop in there, of 3. Divide by 3, divide by 3, divide by 3. That gives me n squared minus, all right, 3 goes in there 14 times, so that's 14n, plus, I think we said 49. You might or might not recognize what I'm looking at. This is a perfect square, which it almost always is unless there's a number, and then it might or might not be. This is a perfect square. So I'm going to let the 3 tag along, and I'm going to try something. I might not be right. I'm going to try this. If this is a perfect square trinomial factor, square root of the first, n. Sign from the middle, minus. Square root of that, 7. Let's check it. Over here to the side, if I had n minus 7 squared, square that for n squared, multiply for negative 7n, double it for negative 14n, square the last one for plus 49. So this was a perfect square trinomial. This could be what you write in my math lab. There is nothing wrong if you didn't see it as a perfect square trinomial and you just were looking at it and said, well, it's a trinomial, so I'll keep the 3 and I'll do this. The last sign is positive, so it's plus plus or minus minus. It is minus minus, n. I need factors of 49. Well, it's 1 times 49 or 7 times 7. They have to add up to be 14. That means I'll take 7 and 7. Check the outer plus the inner. It works. You could write the answer that way. It does not matter. All right, I know this was a long video. It's a long lesson, but it's super important that you be able to factor trinomials.